Okay, so in this video, we're going to take a look at solving absolute value equations. This is basically just the notes that we did in class. The essential question is, can I solve absolute value equations? Now, just as a quick review about absolute value, if I were to ask you, or you see a question that says the absolute value of x equals 8, well, basically it's saying what goes in here that equals 8? Well, it's 8, x equals 8. But because it's absolute value, then this x could also be negative 8. Because the absolute value of negative 8 also equals 8. So we basically have two solutions. So today, even though all we're doing is solving equations, because it's absolute value equations, we're going to end up having to write two separate equations in order to solve. So let's take a look at some practice problems, some examples. So here in number 1, we are going to, here's the equation. So the absolute value of 3x equals 12. All right, all you have to ask yourself is 3 times what equals 12? Because we're looking for the absolute value to say 12. You might be able to do this in your head because 3 times 4 is 12, so you know that x would be 4. But the absolute value of negative 12 is also 12. So x could be negative 4. Now, we don't have to do these in our head, and most of them we can't. But let's take a look at what it looks like here when we work it out. What we do with absolute value equations is that we write two equations. The absolute value of 3x equals 12, so 3x equals 12, or 3x equals negative 12. So we're setting it equal to the positive and the negative. And then, of course, to solve this equation, the coefficient's 3, so we divide by 3. 12 divided by 3 is 4, and negative 12 divided by 3 is negative 4. So our two solutions are going to be 4 and negative 4, okay? So there's our two solutions for number 1. All right, let's take a look at number 2. And the equation is the absolute value of y plus 8 equals 26. Well, that means our y plus 8 can equal 26, or our y plus 8 can equal negative 26. So we set up our two equations. Y plus 8, again, what I just said, y plus 8 equals negative 26. And then to solve these equations, we're going to subtract both sides by 8. So let's just start with this one. If we subtract 8 from 26, 26 minus 8 is 18. So one of our solutions is 18. But over here, when we subtract 8 from negative 26, we get negative 34. So we have two completely different answers that really are the solution to both problems. If you'll notice, like if you plug 18 in to the original problem, 18 plus 8 is 26. So the absolute value of 26 equals 26. However, if you plug a negative 34 into the y, negative 34 plus 8 is negative 26, but the absolute value of negative 26 is 26. So you have two solutions. Okay, let's take a look at this third example here. And the equation is 25 equals the absolute value of y divided by 5. Okay, once you get down to where all you have is the absolute value on one side equals the constant, the positive, then you can set it equal to the positive and the negative. Okay, so we write our two equations. And we have 25 equals y divided by 5, or negative 25 equals y divided by 5. Now, we're not used to seeing these problems where the variable is divided by 5. Normally, it's like 5 times y, and we divide by 5 to get the answer. But since the variable is being divided by 5, we use the inverse of dividing, which is to multiply by 5. So let's take a look at what that looks like in terms of solving it. So you see here that I have multiplied both sides by 5. Over here with the variable, these 5's basically cancel. 5 divided by 5 is 1, so all we're left with is 1 times a y, which is 1y. But we'll multiply the left side by 5 as well. 25 times 5 is 125. And then same thing on the right, but when you multiply negative 25 times 5, you get negative 125. So those are your two solutions. Okay, let's take a look at number 4 in our examples. Okay, and here's the problem. I'm just going to write it out or show you what the problem is. 5 minus 2 times the absolute value of 3x plus 2 equals negative 9. Okay, before we start setting up our two equations, we want to perform the inverse operations that get us to the point where all we have is the absolute value bar. So what we're going to start with, by the way, when this negative 2 is just next to this absolute value bar, it means multiplication. It's kind of like we see parentheses, okay? But before we deal with that negative 2 times the absolute value, we're going to get rid of this 5 out here. This is kind of like a plus, or it is a plus 5. So the way you get rid of a plus 5 is to subtract 5 from both sides. That's the first thing we do, okay? Well, when you do that, you will see that we just, on the left side, it cancels. So we bring down our negative 2 times the absolute value of 3x plus 2. And then on the right, negative 9 minus 5 is negative 14, okay? Now we have to begin the process of solving this. Well, again, this negative 2 is being multiplied by all of this, so we could actually cancel that negative 2 by dividing by negative 2. So we'll divide both sides of this equation by negative 2. And when we do that, we end up with the absolute value of 3x plus 2 equals 7. Now that you have nothing but this absolute value bar, this is where you know that this equals 7 and it can equal negative 7. So you set up your two equations and you solve them. By 3x plus 2 equals 7, you subtract 2 from both sides. 7 minus 2 is 5. Now you will notice that 5 is not, it's not divisible by 3 in the sense that you'll get an integer, but you can just 5 divided by 3. We can just leave it as a fraction. As long as it's a simplified fraction, then that represents the right answer. I mean, technically you could show the decimal that's equivalent to 5 over 3, but we can just leave it as a fraction. On the right side, when you subtract 2 from both sides, you get 3x equals negative 9, and negative 9, when you divide that by 3, you do get an integer, so you can just leave it as x, or the answer is x equals negative 3. All right, last example. So number 5, by the way, on this one, the difference is that we have variables on both sides of the equation, and it does change things up a little bit. So let's take a look. All right. We have the absolute value of 3x minus 10 minus 2 equals 5x. So here's our x on both sides of the equation. Now, again, the first step we're trying to do is to get this absolute value by itself. So we're going to do the inverse operation of minus 2, which is to add 2 to both sides of the equation. Now, when we add 2 to the right side, 5x plus 2, do not get confused. That's not 7x. We just write that out as an expression. These are separate terms, so 5x plus 2. Now, what we know is this absolute value has to equal 5x plus 2. But just like any absolute value, we know that it can also equal the negative of these two, 5x plus 2. So let me show you what that looks like. All right. Basically, we just leave the first equation is 3x minus 10 equals 5x plus 2, exactly what you see. Well, over here, 3x minus 10 equals negative 5x minus 2. And let me just show you what I did. Basically, I just multiplied the negative times the whole right side, 5x plus 2. And that's where we got the minus 5x, which was the opposite of positive, and then minus 2, the opposite of that, plus 2. Then again, you just have these equations that you need to solve. We should be pretty comfortable solving these types of equations at this point, so I'll just show you what that looks like. You get your x's on one side, you get your constants on the other, using your inverse operations, and then you solve it. You'll see here on the left side, it says negative 2x equals 12. When you divide by negative 2, you get negative 6. So x would be negative 6. On the right, when you work it out, you get 8x equals 8, and you divide by 8, and x equals 1. Now, I want to show you, okay, on the left side, we got negative 6. But if you think about it, if you come up here where it says the absolute value of 3x minus 10 equals 5x plus 2, well, if I replace this x with a negative 6, 5 times negative 6 is negative 30. And negative 30 plus 2 is negative 28. Well, the absolute value of something can never equal a negative number. So that negative 6 would actually be what we call an extraneous solution, and it would not be one of the solutions. We're going to talk more about that in our next lesson over absolute value equations, but I wanted to introduce that in this lesson. When you plug in the 1, 5 times 1 is 5 plus 2 is 7, and the absolute value bar can equal a positive 7. So 1 would be one of the solutions. All right, that's a quick look at the notes that we took in class. Hope that helps.